This is 7.2, so this is the second part of our Unit 2. We're staying with derivatives, but we're working into trigonomic derivatives now. Okay, and as I explained this right here is our sine graph. This is our cos graph. Okay, get used to radians, okay, and comparing them to degrees. So like pi over 2, that's going to be 90 degrees. Pi, that's 180 degrees. Kind of make those connections with radians and degrees. Okay, your calculator has a radian and degree mode. Okay, so make sure, remember we're always supposed to be in degree. When you're doing this stuff, you might want to be in radians if you're using the pi over 3s and whatnot. When you're doing your homework for now, but your tests you won't be able to because you have the chart in your formula sheet. Okay? Alright, so the first thing we're going to talk about, and we're not going to go through the proof very much, but guys, this is the definition. Derivative of sine is cosine. Okay? Derivative of sine is cosine. That's all you need to know. Whenever you take the derivative of sine, it's a cosine. Okay? That proof, here's the proof. Okay? When you work through it, everything cancels out to being just a cosine. Okay? The reason, if we go back to the picture real quick, the reason is that if, see this right here, this top of this hill on sine, that's 0, right? So, but look, cosine goes through 0 at that point, so that's why they're derivatives of each other. So the tangent slope of that, excuse me, of that hill is 0, cosine's going through 0 at that point. So that's how they're related. So derivative of sine is cosine. Right. And we're going to talk about what the derivative of cosine is later. I'll come back to this picture because we can also make sense of what that is as well. Okay, so do you guys not see that, or I feel some confusion? So right here, see how that hill, on this hill, this tangent slope at the top of the hill is 0. In the same exact spot, that's where cosine's going through. So cosine's going through 0, which gives us the same value. Okay, so that means that cosine is the derivative of sine. Because this right here, we understand that tangent slope, f prime of that, m equals 0. Well, cosine's telling us it's getting 0 at that same point. That's why it's the derivative of it. No, the tangent slope of sine, yes. Right. For this one? Yes. So what I'm saying is that we understand that when this changes direction, the tangent slope is 0, right? That's a flat line. And cosine's representing that number with its graph. So therefore, cosine, this graph, cosine, is representing the derivative of sine. Okay? So like, remember how we talked about our derivatives, and they were a linear equation, right? Or they were parabolas. They represented the slope change. Cosine represents the slope change of sine. Okay, so if you look here, right here, at negative pi over 2, again, it hits 0. Right, because again, it's a change of direction. Okay, is that good? Okay, so again, here's the proof. The proof, no. I'm okay, like, you're just going to use this, and it's on your derivative thing. So you don't have to really memorize that. Just understand the derivative of sine is cosine, and I hope the picture illustrated that for you. Okay. All right, so now the derivative of cosine is negative sine. That's the two that we're getting today. So derivative of sine is cosine. Derivative of cosine is negative sine. Proof's a lot shorter here. Okay, so if I take the derivative of cosine, they're just putting in pi over 2 minus x, because pi over 2 minus x would be the same thing as cosine, but let's look at the picture. So cosine, every time it changes direction right here, right? That's where 0 is, right? But it's right there, but it's the opposite because when it switches, because we need to see more, I'm sorry, this one and this one is also 0, and so it's negative 1 there. And it's negative because I think it's because it's going the opposite direction in terms of the radians, but we'll get to that later. Can't see as well in the picture, but I think you get the idea that it's still they're related. So I guess just trust me on the negative for right now, and we'll get to that a little bit later. Yeah, that might be it. Oh, yeah, that's why. Okay, good. So on the cos is still changes here, but Jeremy's saying, because we're on you're saying like right here it's going down at negative, like a negative direction. So before, like here, let's see here, hold on. Right here. Yeah, all these are going, but they're all doing that. So I'll figure out why it's negative, but either way, it's still related, because the reason we can't tell it's negative, because right now we're talking about tangent slopes of 0, right? If it's 0 for positive or negative, it wouldn't matter, because 0 of a negative and 0 of a positive would just be 0. So right now it's kind of hard for me to show you this illustration because of the negative. That's the problem. But I'll give you why it's negative in a little bit. Is that okay? So all you need to know is they have the same. All you need to know is that sine and cosine, they represent each other in terms of their derivatives. Okay? But when it's 0 or all the time? All the time. Okay, all the time. It's just 0 is the one that's clearer to see in the picture. But honestly, so if I wanted to figure out at, let's say pi over 6, which is not a nice even number, which would be right about here, that slope would be right there, whatever that is. Whatever I'd get for that piece. Right. Okay. All right. So those are the two things that we're introducing today. So now when we look at this, but the thing that you have to understand, and I know we're still a little bit foggy or not comfortable with chain rule, when you take derivatives of trigonometric functions, you have to chain rule with what they're being sine of. So what I mean by that is, we know the derivative of sine is what? Cos. So I'm going to write cosine 3x, and I have to chain rule of what's in the sine. So what's the derivative of 3x? 3. And that would be your answer. Yep, that's how I'd prefer you to write it. So for, sorry, I have y's up here, so we'll call this is y prime equals 3 cos 3x. That's the derivative of sine 3x. Yep. Okay, because we have to do chain rule. So I'm taking a derivative of this, which is cosine 3x. And I'm taking a derivative on the inside, which derivative of 3x is 3. Right, so I look at it like this. And so that to me, it makes me see something inside. And that's how, like, see how x plus 2 has the parentheses this time. So everybody okay? So part B, okay, if we're going to part B, that would just be y prime. It'd be cos x plus 2, but the derivative of the inside is just 1, right? It's just an x, so I don't really have to put a 1. That's all it is. And then C is just kind of like a definition, okay, where D is a constant, K is a number in front of X. That just kind of general rule would be, not double prime, what am I doing? That would be K cos KX plus D. That's what that would be right there. Just that, the K, because derivative of something in front of X is just that thing in front of X. So that's all, that's just a definition thing. I know it's weird, it's letters. Just like right here, we had 3x, we put a 3. If you have a kx, you're going to put a k. It comes out, because d is just a constant. Okay, any questions? So, I mean, it's pretty much the same rules. Okay, nothing's really changed too much, which is nice. And it's just, and you get the rule, you get those derivatives. So, I mean, all in all, it's just following what you're given, I hope. Okay, so this one here, we already, I did these separately, sorry. I didn't need to do that. I forgot they were so easy. Okay, so example 2. Okay, we have 3 to do here. So let's look at the first one. Did I separate these? That was stupid. Okay, all right. So sine x cubed. Okay, so what do you guys think? What would this one be? 3x what? Good. 3x squared out. Okay, not sine. Cosine of x cubed. Yeah, it's just easier to put in front because it's. I mean, you don't have to, Dar, but it looks better, I think. No, not really. It's just, I mean, I know we're putting it out here, but because to me this is a number, it's a constant, and this is a trig, so I like to put the number in front. I don't know. So you're doing the derivative of the inside first, but it's going to end up at the front anyway, so just do that. Right. I mean, and that's just something like, Dar, what I'm saying is, Dar, you can still write like this, okay? I don't care. This is still right. You're fine to do that. I just, like, your book's going to put that in front. I don't really know why in terms of, like, what the order rules are, but it just looks a little better. Yeah, that's all I can say. Okay? All right, so then B. Okay, let's try B now. So let's see. Now, this is good, and I want you to star these because these are misconceptions, okay? It looks weird, but sine, does anybody know the difference between these two? That's correct. This is shorthand. This is notation for this. Like that. What? It could also be written without the bracket, right? No, because you need the bracket to know the sign's being hit. Because if you don't put a bracket, then it just looks like this. Do you see what I'm saying? So the difference is x is only being cubed. This is saying your whole trig function's being cubed. That's what. And I 100% agree with you. Okay? But just, Abby, all I'd say is if it's on the sign, that means it's on everything. Okay? If it's on the sign, that means it's on the whole thing. Okay? Now, and Abby, at the same time, it's not going to be that hard on you because I think you would still do the same thing because we have to use what here? Chain rule. So I drop the 3, I keep the sine x, I have a 2 now, and then what do I have to do last? The derivative of sine. So I just have a cosine x come out. And I think you'd do that here, I'd hope, the same way, even if you looked at it that way. But which is 1. But for this one, just take the good. If I had to take the derivative of this, and there was something in there, it'd be like a 2-piece, because I'd be doing this stuff too. Just, yeah, but yeah. So hold on. I know it's going to get worse, but. Yep, just cos x. Cos x, that's the derivative of the inside. Okay, cool. Let me just put it on my desk. Thank you. Any questions on that? Because now we're kind of starting to unwrap what we're going to be doing. So on the next one, good. Yep, this is just getting ahead of what Morgan was asking. So, Abby, maybe if I'm you, I know you're frustrated, but I would just go ahead and just write it like this and put the whole thing cubed. I just would just get in the habit of just doing that. You guys see that? I did that because there's a cube on the sign. Yeah, this is where you start to love calculus. This is where it starts to be the dumb mistake thing. On your final, you want to make sure you're organized. So just do your first thing. Just drop your 3. Keep the inside. And then you have a 2. Derivative the inside. I have to take the derivative of sine, which is cos. Okay, I'm just going to put an arrow that's next to each other, okay? So it's going to be cos x squared minus 1. And then what? Yes. And then derivative of the inside. So it's chain in a chain. That's correct. So can you multiply the 2x to the 3x? You can. Okay. So what you can do now is you can put the 2x with the 3. So you can have 6x. You can leave it written like this. The book's going to put it back like this, but I don't care. That's fine. I'm going to leave it this way so I don't make Abby mad. Okay, like that. And then cosine is on the end. That would be the derivative there. No. You can't pull the x squared minus 1 because they're blocked by a trigonomic. Cosine x squared minus 1 is its base itself. So since sine and cosine are different, you can't. But what gets fun, I think it's fun, it's more like puzzles. And I think I put them on there, maybe not, but I will give you trig identities where you can see some patterns. You're like, oh, that equals 1. Boom, it goes away, it's 1. Yeah. But it's nice because a lot of times they make your life easier. You're hoping to find them. Okay? Yep.
Okay, and I just walked, so you brought the 3 down, put it
Yep.
the square.
Yep.
And then you multiplied it by
The derivative of this big chunk.
Yeah.
Yep.
And then you multiplied that
By derivative of this chunk.
of that.
Yeah. Because it's like chain in a chain. Because I had double, essentially I have double parentheses, so I have double chain.
Okay.
Okay. Anybody else lost? It's all right. Let's pause the video then. There we go. Some positive. So now we're gonna do this one with the product rule because we have an x squared times a cosine x. So it's just don't forget it's first derivative of the second plus derivative of the first. Right. That's correct. Okay, so you guys ready? I'll wait for you to write it down.
Yeah.
So first is x squared. Derivative of the second, as Morgan just said, is negative sine x. Plus second. Derivative of first is 2x.
Wait, why did the cosine go positive then?
Why did it go to positive?
Like, oh, sorry, never mind. I get it.
Yeah, yeah.
It wasn't the derivative.
Yes, correct. Okay, so then just to simplify this, I'll just put the negative in front. So I put negative x squared sine x plus 2x cosine x. I just put it in front because it's a negative 1. Just looks kind of weird being like this.
Yeah.
So, and that's done. I can't do anything else from there. Yeah. Because there's no simplifying I can do there yet.
So later on, we'll do like different values for x.
Yep.
What do we need our graphic calculator? How do you
No.
solve cosine?
Well, you'll see. I'll show you. What's up? You'll see. It's not going to be decimals and stuff. It's going to be like you're going to put in pi over 2. So if you put pi over 2 for sine is 1. It makes your life easier actually. So that's 1. Pi over 2 there, that's 0. This whole thing's gone. Yeah. Okay? Because like I said, if I put pi over 2 here, this whole thing's gone. Right? And then this thing, that's all I get my answer, which would be pi over 2 squared. That'd be your answer. Pi squared over 4. Right. At that point. Okay? Go ahead, Nick. Yep. Thanks, bud. All right. Okay, what's the next one here? All right, so so I have a sine x plus a sine y, so what pops into your head? Implicit differentiation, yes. Okay, it's okay, it's not that bad. Look, it's only this much on my notes. That's it. Oh, see, you guys are all about shortcuts. Okay? All right, so all we're doing, we have the implicit differentiation to have x and y together. It says derivative of y with respect to x, that's still dy dx, so we're still trying to get that by itself, not forgetting from unit 2 before. So derivative of sine x, that's just a regular x, so we do that one normally. What is that? Okay, so y prime, oh, nope, I can't do that because we're going to solve for dy dx, sorry. Okay, so I get cos x. Okay, what's derivative of sine y? Cos y dy dx. Right? And the derivative of 1 is 0. All you do, minus the cos x. Cos y dy dx equals negative cos x. And we just divide the cos y off. And you're done. So the derivative is negative cos x over cos y. See, not too bad. All right, now we're getting ready for the hard one, and this is our last one, and we'll stop. Roughly that from where we did before, the rest of the page. Okay?
Oh, are you serious?
Yeah, be down to because we're doing a point. So now we're doing. All right. So the first thing is that okay? You see it. Hopefully, we're gonna have to do quotient rule. Second thing is that remember it wants the equation. So that means we're gonna have to do our y equals mx plus b thing. So we do need the y. So before we start, let's go ahead and get this point instead of just having the pi over 6. So what I'm saying is we have pi over 6 now. We'd like to have a y value. Okay, so all I'm going to tell you is sine of pi over 6. What is sine of pi over 6? Pi over 6 is that, okay, yes, it's 1 over 2. Okay, so when I put pi over 6 into sine, it's 1 over 2. Now, 2 times pi over 6 is what?
2 pi over
6, which is, what's that reduced to?
2 pi over 3.
So what's cosine of pi over 3?
Pi, 1/2.
1/2 again. What's 1/2 over 1/2?
1.
So we got our y is 1.
Okay, so
Kind of.
you know that your x value is pi over 6.
Right.
And then
We plug that in for x's
you plug that in for x in your original equation
to get y.
to get y, and then that ends up being 1.
Yes.
Okay.
Yep. Same thing you're doing exactly, but we just have just with trigonometry now. Okay. All right. So I'm going to erase that 1/2 over 1/2, and we're going to start our quotient rule here. All right. Here we go. Okay. So low d high. So cosine 2x. Derivative of high is what? Cosine. Okay, minus high. D low. Okay, what's derivative of cosine 2x? Right, negative sine 2x with a 2, because of the chain rule. Go ahead.
Oh, because it's like a bracket. And
Right, the 2 came out. Okay, so then we have, yep, it's a chain, like this. So what I'm going to do real quick here on top, for we put low squared is, I have a 2, a negative, and a negative. So I'm going to make that a positive 2. Okay, so this is what we have. We have cosine 2x, cosine x, plus 2 sine x, sine 2x. That's what we have on top. Our bottom is cosine 2x squared. Yes? So all I did here, so what I did here was 2, negative 1, and a negative 1 is a positive 2. And then sine x, and then just kept this. I just multiplied my constants in front, my coefficients. So 2 times negative 1 times negative 1 is a positive 2. I kept these two things. Okay, I don't see any simplification I can do. There's no cosine 2x to pull out to cancel. There's nothing I can do. So right here, we go ahead and we plug in pi over 6. Okay, and we're trying to get values now because we can get values of all these. We kind of already know them. Okay, so like cosine of 2x at pi over 6, we already know that's what. What'd she get? She told me this is 1/2. Okay, so I'm going to put 1/2. I plugged it in for the first one. Okay, what's cosine of x? So what's just pi over 6 in for cosine? That's going to be the longer one, right? Root 3 over 2. Are we okay? All I'm doing is I'm plugging pi over 6 for each of these x's here.
Yeah.
Plus a 2. What's sine of pi over 6? The 1/2. And then what's sine of 2 times, so pi over 3? Okay, And the bottom is going to be all over what? 1/2 squared, which is 1/4. 1/2 times 1/2 is 1/4. Okay, so other than the fraction mess, it's not too bad. Okay, so this right here is going to be √3/4. This right here is going to be √3/4, but 2 √3/4. Do we see that? Right. So these are common denominators, so now I can add these. So all I did was √3 times 1 times 2 is 2 √3. 2 times 2 is 4. 2 times 2 is 4. 1 times √3 is √3. As you just said, Morgan, 2 plus 1 is 3 √3/4, and it's all over 1/4. So what's going to happen with that? What you liked what I said last time, Dale, after the 4? Okay, good. And so a 4 is on top, a 4 is on bottom, so what happens to the 4s? They cancels. So essentially, your answer is just 3 √3. Okay? That's your slope.
I'm confused.
Sure.
When you have the cos 2x, what do you look for in here? Or like how do you?
Well, because you have to plug in, you just plug in pi over 6. That's what she did. So you get 2 pi over 6.
Yeah.
Right? What's 2 over 6 reduced to?
Oh, pi over 6.
So then we look at pi over 3.
Multiply whatever that.
Right. You simplify it to one of those, hopefully.
Yeah.
Yes. Yep, 12/4 though. And then so it just comes back out. So that's why I said like you can just essentially cancel them. So now we're going to find the last thing we're going to do here, guys. We're going to find this what the y equals mx plus b is. So 3 √3x plus b. And that's where we wanted to have our x and our b. So we have 1 equals 3 √3 pi over 6 plus b.
That's some messed up stuff.
Yep.
We just multiply those two together and then divide it or subtract it out.
Would it be like 3 pi over 6?
It would be, so all you got to do is you're just solving for b. So this right here is a package, so we're just going to minus this over. That's equivalent to b. That's all you have to do.
No.
Yeah. I won't make you guys do common denominator with that for right now, but so then you just to write this in terms of being done would be plus, since that's your b. And I'll figure out what we'll do with the pi over 6. The pi over 6 won't be a problem. But that is where we're going to stop today.